The manual vertical milling machine is the most used machine in the machining world in terms of numbers of machines. There are over 20,000 machine shops in North America, and every one of these shops has one. You might notice that a vertical milling machine looks a bit like a drill press. And a way it is, just with much more power, precision, and many more capabilities to manipulate the tool and the workpiece or blank during a milling operation. Milling is an art form as much as a technical skill. Quality of work depends more on the machine operator than on the machine itself. In most cases, the most efficient and cost-effective way to produce small quantities of milled parts is with a manual milling machine. With some parts, depending on the shape and complexity of the part, a manual milling can be set up to make parts as efficiently as a CNC machine. For these reasons and more, there will always be a demand for manual milling machines. There are other types of milling machines such as horizontal mills, bed mills, and others, but vertical mills are by far the most common and the ones that our customers generally use. The mill you see here is a typical manual vertical milling machine, or knee mill. The term knee mill refers to the shape of the machine. Milling machines like this are often referred to as Bridgeport. Bridgeport is a company that was one of the earliest and largest manufacturers of milling machines, and the term Bridgeport became the generally used name for all milling machines for many years, much like plexiglass was used for all acrylic sheet or Kleenex for tissues. The basic technology for milling has changed little over the years, and it is common for milling machines to operate effectively for 40 and even 50 years and more when properly maintained. Milling machines come in many sizes, but they can be a little bit smaller and much larger. Of course, the larger machines are designed for working with much larger workpieces and making much larger parts. This mill has a work envelope, in other words, is capable of working with a piece of material up to 36 inches by 18 inches by 12 inches. These are the X, Y, and Z axis dimensions in that order. And by the way, this is a 3-axis milling machine, as most are. Here you see the bed of the milling machine moving in the X-axis, or direction of travel. The bed is the flat platform that material is attached to during machining, usually using a vise, as in this operation. As the operator stands in front of the machine, the movement of the bed is left to right or right to left. That is the X-axis for this machine. The movement of the bed away from and toward the operator is the Y-axis, and the movement of the spindle up and down vertically is the Z-axis. It is the combination of movement of the cutting tool, called a mill, in concert with the mill bed in all three of these axes that allows for the geometry of the parts to be achieved. The part of the milling machine that holds and rotates the mill, or the tool that does the cutting, is called the spindle. The part that spins the tool, using a chuck to accommodate different types and sizes of mills. Manual machining requires manual tool changing between every operation that is required to finish a part. A mill is a tool that has cutting edges or points. These cutting edges or points, as they are exposed to a surface as the spindle spins the tool, literally slices extremely thin sections of material from the workpiece. You are watching a milling process called fly cutting. A fly cutter is a type of mill or cutting tool. It is a very common process for precisely removing material on flat surfaces. This particular fly cutter has 3 cutting points and is spinning very rapidly and precisely removing small amounts of material from the edge of this piece of clear cast acrylic. Cast acrylic, while it does not have particularly good mechanical properties, machines very well and is often used for machined parts where transparency of the part is required. This material that is flying off the workpiece is called the chip or chips. The machinists love it when the chips are small and move away easily and readily from the workpiece, as you see here. Many of our plastics machine beautifully, acetal for example, as well as PET, high performance materials, and many others. Some plastics like nylon and polypropylene can form strings as material is being removed, and they sometimes become wrapped around the workpiece or spindle and stop the work in progress while the beehive is being cleaned away. Here are a few common types of mills. Here's a fly cutter like the one you saw in the video. used for precisely cutting and removing material from flat surfaces. This is a ball nose end mill. Note the rounded end of the mill. It is designed to cut rounded features into a workpiece. They come in hundreds of sizes with different radii from which a machinist can choose. This is a carbide end mill, one of the more common types of mills. The cutting edges are tipped with carbide, a very hard material that helps maintain the sharpness of the edges. It is a rule of thumb that carbide tools should be used when machining plastics. This is a roughing mill. This kind of mill is used to remove large amounts of material from a workpiece prior to precision finishing. Roundover mill. Note the contour on the side of the mill. This mill puts a rounded edge on a workpiece. Slitting saw. This kind of mill acts just like a saw blade and can cut slots, grooves, and other similar features into parts. Stepped counterbore mill. This mill can drill and counterbore a hole in one operation. Note the two diameters on the tool. Standard drill. Milling machines do a lot of drilling too, typically as one of several operations. Note the handles turning on the left and right side of the mill bed. This milling machine is equipped with motors to move the mill bed in the X-axis, and this is quite common. On a purely manual milling machine, this would be done with hand cranks. The machinist, in a very manual process, is cleaning the work area and then turning the workpiece over to cut the other side. This is commonly called qualifying, taking a blank that was furnished oversize and then removing material in a very precise way from both sides to bring the material within the called out dimension, typically the dimension of the finished part on this feature, and making the cross section very straight and square and putting a good machined finish on the surfaces. You've probably heard the terms feed and speed. This is what you see here. The speed that the spindle, and thus the mill, is turning is the machine speed. The speed at which the material is moving through the cutting area is called the feed or feed rate. These are two critical aspects of milling and other types of machining as well. Choosing the proper feed and speed for different materials and different kinds of surface finishes, in other words, how smooth the milled surface is, are the two most critical aspects of the machining process in producing parts that meet the specifications. As we take a wider look at the milling in process, notice the electronic readout at the top and right of the image. This is called a DRO, or digital readout. These track and display the movement of the machine in the three axes in increments of 4 decimal places. In other words, with more precision than is typically required, but that is within the capability of the DRO to indicate. This is how machinists know how far to move the tool and/or workpiece with each process in order to create the part within specified tolerances. On a purely manual milling machine with no add-ons, the machinist uses visual dial indicators on the hand cranks and levers to achieve this. They can still produce extremely precise work, but it is tedious and time-consuming work compared to working with a DRO. Most milling machines these days are equipped with DROs. There is of course much more to milling machines than we have seen here, but this covers the basics. You'll see things in upcoming segments that will be similar to what you have seen here. Router cutting, for example, shares many characteristics with milling, as does turning. Let's take a look at CNC mills and machining centers next.